Hello everyone, I welcome you all to another revision lecture for NEET for chemistry subject. Now in this particular session, we will be focusing on to the questions from the physical chemistry part of the entire chemistry. Okay, so we are going to have different questions dealing with different chapters. So now let's have a look at the very first question here. Now this particular question is actually based on the chapter solutions, and here we are basically dealing with the vapor pressure and Raoult's law in this particular question. Okay, so the question here is, on mixing heptane and octane, they form an ideal solution. At 373 Kelvin, the vapor pressures of the two liquids, like basically components are heptane and octane, they are 105 kilopascals and 45 kilopascals. So you have been given the vapor pressure of these components in their pure state, that is 105 and 45 kilopascals respectively. The vapor pressure of the solution, which is obtained by mixing 25 grams of heptane and 35 grams of octane, will be. Now you have been given the molar masses as well for these two components. Okay, now we know that this particular question is typically based on Raoult's law for two volatile liquids, isn't it? So if we want to find the vapor pressure of the solution, the total vapor pressure of the solution, we have the formula here as PS, which is equal to P01 times X1 plus P02 times X2, right? This is a direct formula for the Raoult's law. Now you have been given P01 and P02, of course, right? Why? Because they are basically the vapor pressure in their pure state, isn't it? And X1 and X2 we can definitely find, isn't it? So once we plug in the values for the mole fractions as well as the vapor pressure, you will be able to get the answer. So the first thing which you need to do here is, let's suppose if I find the number of moles of heptane here, okay, so the number of moles of heptane here is definitely going to be what? 25 over 100, right? That is basically the number of moles of heptane, which is obviously coming out to be 0.25, and number of moles of octane will be 35 over 114, which comes out to be 0.30. Now these are the respective moles, right? Now when we find the mole fraction, so obviously here you will have X1, which is equal to what? N1 over N1 plus N2, right? So basically here you are having 0.25 divided by 0.25 plus 0.30, right? So here you have 0.25 over 0.55. So from this, obviously you have the mole fraction for component 1, that is nothing but, let's suppose here you are dealing with what? Heptane. Okay. Similarly, you can find it for X2, right? Now to find the mole fraction for X2, now so suppose if I just calculate here, it is basically for the mole fraction of X1 you are having 0.25 over 0.55, right? So that comes out to be 0.45. Now this is the mole fraction for X1, that is for heptane. So X2 will be 1 minus X1, right? We can directly find it as 1 minus X1 because it is a binary mixture. So sum of the mole fractions of both the components should be equal to 1, as we know. So X2 here without any doubt will be 0.55. So once we have found the mole fractions here, right, we can plug in those values into these expressions. Now we already know P01 and P02, right? Now here if you look at the options, you are having 72 kilopascals, 39.75 kilopascals, 96.2 kilopascals and 144.5 kilopascals, right? Now if you notice, first and foremost thing, the values for the individual vapor pressures are 105 and 45, okay. So the value for the overall vapor pressure of the solution, actually speaking, should be contained within these two limits. So option D is definitely out of question here, right? It cannot be the answer. 72, 39.75 and 96.2. these definitely fall in between. But now if you notice here, the mole fraction of octane is relatively higher compared to what mole fraction of heptane. However, its vapor pressure is lower. So when you will find the answer, you will realize that your answer will be close to 39.75. Okay, it is actually somewhere around 36. So that should be your answer. Okay, kilopascals, right? So when you do the calculation, you will definitely get this particular answer. Now, this is one type of a question which is based on Raoult's law, right? Now, another type of question which they can ask you is basically to find the mole fraction of any of the component in the vapor phase. So if they are asking you to find mole fraction for any of the component in the vapor phase, we can directly use the Dalton's law of partial pressure, right? So when you do that, we know that partial pressure of any component is nothing but total pressure multiplied by the mole fraction. Now here, Y is actually mole fraction of the component in the vapor phase. Okay. Now this particular relation which I have written is as per Dalton's law. But as per Raoult's law, we know that P is nothing but P naught times X. Yes or no? So if I want to write this particular expression for any of the components, so let's suppose component 1, we can say it is P naught 1 times X1, which is equal to Pt times Y1. So here Y1 we can find, that is nothing but P naught 1 times X1 over Pt. Now Pt here is basically total vapor pressure of the solution. Remember this. Now the way we have found the mole fraction of component 1 in the vapor phase, similarly you can find it for component 2 as well. So please remember this particular formula as well. Right? So your answer here for this particular question is close to 39, right? Actual answer will be around 36. So that should be your answer, option B. Okay. Moving on with the next question. At a certain temperature, a 5.12% solution of cane sugar is isotonic. It is isotonic. The moment we say isotonic, it means what? We are dealing with identical osmotic pressures, right? So at a certain temperature, 5.12% solution of cane sugar is isotonic with a 0.9% solution of an unknown solute. So the question mark is, what is the molar mass of the solute, right? They are asking us to find the molar mass of solute here. So now here, because they are saying that two solutions are isotonic with each other, we definitely can say that pi 1 should be equal to pi 2. Then osmotic pressures are same. So if I consider this pi 1 which is equal to pi 2, can we say here that basically C1 RT1 which is equal to C2 RT2. Now because they are saying the same temperatures, obviously T1 and T2 will be the same, R anyway gets cancelled. So basically their concentration should be same here. Now here they are giving you the concentration in terms of percentage. So we are dealing with 100 grams of the solution in both the cases, right? So basically this particular expression is reduced to N1 which is equal to N2. The number of moles for both the components, that is for cane sugar and this unknown electrolyte, unknown solute, should be the same. Okay. Now here they are saying that it is 5.12% solution of cane sugar. What does it mean? It means 5.12 grams of cane sugar is present in 100 grams of the solution. Simple, straightforward. Yes or no? So the mass of cane sugar which we can consider here is 5.12. Same is the case when we consider the unknown solute. So here you are having 0.9% unknown solute. What it means is 0.9 grams of this solute in 100 grams of solution. Yes or no? Okay. So now here let me write the answer that number of moles is going to be 5.12 divided by 342, which is actually the molar mass of cane sugar, which is equal to 0.9 divided by molar mass of this unknown solute, which we have to find, right? So now here definitely when you solve this answer for M, that is molar mass of this solute, it is going to be 342 times 0.9 over 5.12, right? Which gives you the answer which is nearly equal to 60. So without any doubt, your answer here for this particular question should be option A, 60 grams per mole, right? So understand this particular thing, that whenever they are saying that two solutions are isotonic, it means their osmotic pressures are equal, and from that obviously you can definitely find the molar mass or mass of a given solute, right? So I hope you got the clear understanding of this particular question. Let's move on with the next part here. Question is, the degree of dissociation of a weak electrolyte, that is AXBY, is related to the Van 't Hoff factor by the expression. Now you have been given different expressions here, right? Now I'm sure that you guys must have done these kind of questions, and the answer for this particular question is definitely option A, right? Now let's try to derive this particular expression here. So once we say that here you are having this particular electrolyte AXBY, now because it is a weak electrolyte, it will undergo reversible dissociation like this. So X moles of A, Y plus Y moles of B, X minus. Yes or no? Simple, straightforward. This is the dissociation. Now let's suppose initially in the solution we have added 1 mole of the AXBY. This is the salt, right? So obviously initially the number of moles of AY plus and BX minus is going to be 0 and 0. Now once equilibrium is reached, let's suppose the alpha moles of AXBY underwent dissociation, okay? So the change in number of moles here will be, let's say, by minus alpha, and this will be what? Plus X alpha, and this will also be plus X alpha. Yes or no? Right? So if I want to find now the total number of moles of AXBY remaining into the mixture is going to be what? 1 minus alpha. For this is going to be obviously X alpha. This is going to be, sorry, this should be Y. This will be what? Y alpha. Right? Therefore, we can say that the total number of moles in the mixture, in the solution, can I say it is going to be 1 minus alpha? These are the moles of AXBY remaining, plus X alpha plus Y alpha. Yes or no? So now definitely we can say here it is 1 minus alpha, alright, 1 minus X minus Y. Yes or no? So these are the total number of moles in the solution, right? So we can say that these are nothing but NO, that is nothing but observed number of moles. And we know that theoretical number of moles we have taken initially is how much? 1 mole, right? So number of moles theoretical is nothing but 1 mole. Yes or no? So we know that Van 't Hoff factor I is equal to the ratio of number of moles observed to number of moles theoretical, isn't it? Now number of moles observed, we know it is 1 minus alpha, 1 minus, now can I write this as X plus Y? If I am taking the negative sign out, these are the total number of moles which are there into the reaction mixture, divided by, when I say theoretical number of moles, we have taken it as what? 1, right? So in short we are left with I, which is equal to 1 minus alpha, 1 minus X plus Y. Yes or no? So definitely we can say here that if I take this particular part towards the left hand side, so obviously we can say here that alpha times 1 minus X plus Y is equal to 1 minus I, right? Very much clear? So definitely from this, when we find the expression for the alpha here, so we can say it is alpha is what? 1 minus I over 1 minus X plus Y. And if we multiply with the negative sign both the sides for the numerator and denominator, definitely my expression would be I minus 1 over X plus Y minus 1. Yes or no? So that obviously matches with your option A, right? So this is a general expression for the relation between alpha and I. Likewise, you could have different types of salts. So suppose if I am saying that AB type of salt, so in that case your X plus Y should be equal to 2. That is nothing but the total number of particles which are produced by that particular salt. Okay, so depending on the type of salt, you will be able to write this particular part, and of course you will be able to determine the correlation between alpha and I. But yes, this is the general relation. Okay, now just for your information, in this case there is a dissociation happening, but if you have any question which is related to the association of the electrolyte, so you need to know this particular relation, that is alpha is equal to 1 minus I divided by 1 minus 1 over x plus y. Basically again the number of particles, right? So I can also put instead of x plus y as n dash. So either way it's perfectly fine. Okay. N dash is nothing but number of particles undergoing association or dissociation, or rather in this case it is just association. So this expression please remember for association, and of course this is for dissociation, that's why your answer is A here. Alright. Okay. Moving on with the next question here. A binary liquid solution is prepared by mixing N-heptane and ethanol. Which one of the following statements is correct regarding the behavior of the solution? Okay. Now before we discuss the options, have a look. N-heptane, first of all, it is non-polar. It is a hydrocarbon, yes or no? And ethanol, we very well know that it is a polar molecule. In fact, it shows hydrogen bonding as the intermolecular interaction. So we can say here it is hydrogen bonding, right? Now they are mixed. So definitely when they are mixed, the interactions are not identical, and definitely if the interactions are not identical, it is not going to form the ideal solution. It is not going to form the ideal solution, right? Okay, so if you look at option A, the solution formed is an ideal solution, definitely is not the answer. The solution is non-ideal, that is correct, but let's have a second part of it. The solution is non-ideal, showing positive deviation from Raoult's law. The solution is non-ideal, showing negative deviation from Raoult's law, and finally N-heptane shows positive while ethanol shows negative deviation from Raoult's law. Okay, now because we are having ethanol which is having what hydrogen bonding, but the moment you are mixing it with N-heptane which is actually a non-polar solute, what it is going to do is it is going to break the interactions which are present between the ethanol molecules. So let's suppose if I say there is hydrogen here, there is oxygen here, and they are already bonded to each other through these hydrogen bonds, right? Okay, these are the interactions, let's suppose, present in ethanol. When we add N-heptane here, it is going to come in between these particles. They are going to break these interactions, and because of which the relative escaping tendency is going to increase for both the components. And because the relative escaping tendency is going to increase, the overall vapor pressure of this solution will also increase, right? And because there is increase in overall vapor pressure of the solution, definitely this mixture will show positive deviation from Raoult's law, right? Because we can say here that PS is greater than P01 times X1 plus P02 times X2, right? Yes, so definitely your answer here is B, that is it shows positive deviation from Raoult's law. I hope you got the clear understanding about this question. Alright, moving on to the next question here. The density in grams per ml of a 3.60 molar sulfuric acid solution which is 29% H2SO4. Okay, now the moment they give you this percent, and if they have not given you any indicator for that, whether it is weight by weight, weight by volume, or volume by volume, by default we consider this as percent weight by weight. Remember this, we will be considering this as percent weight by weight. Now here they are asking you to find the density of the solution. They have given you the concentration, that is nothing but molarity of the solution, right, and percent weight by weight. So we have a direct relation. I hope all of you know that particular relation, that is molarity of any solution is equal to PD10 divided by molecular weight of the solute. PD10 divided by what? Molecular weight of the solute, wherein this P is nothing but percent weight by weight, D is definitely density, 10 is just a number here, and molecular weight is for the solute here, which is nothing but sulfuric acid. Now you have been given the molarity, which is nothing but 3.60, which is equal to, percent weight by weight is given to you as 29%. Density we have to find 10 divided by molecular weight here is nothing but 98. So when you solve this for density, that is D is equal to 3.60 times 98 over 29 times 10, which gives you the answer as 1.22 grams per ml. Okay, so definitely here your answer is D, right? I hope you get the clear understanding. Please remember this particular relation, which is between the molarity and the percent weight by weight and density of the solution. Next question here. A solution containing 2.675 grams of COCl3.6 NH3, which is having a molar mass of 267.5 grams per mole. Okay, you have been given the molar mass. It is passed through a cation exchanger. The chloride ions obtained in the solution, they were treated with excess of silver nitrate to give 4.78 grams of silver chloride. Then the formula of the complex is, the formula of this particular complex is, right? Now definitely we know that this particular complex is a coordinate complex. It is going to involve coordinate bonds, right? And all the more we know that the coordination number for cobalt generally it is 6, right? So now the question is, you have been given these 4 options. These are all coordination compounds, right? We have to choose which of these is going to be the correct answer for us. Now look here. They are saying that 2.675 grams of this particular complex has been taken. So if I find the number of moles, first of all, we have 2.675 divided by 267.5. So without any doubt, it is 0.01 moles. So we have taken 0.01 moles of this particular complex, right? And when it is passed through a cation exchanger, the chloride ions which are obtained, they were treated with silver nitrate solution. But how much of AgCl are we getting here? 4.78 grams of AgCl. So if I find the number of moles of AgCl here as 4.78 divided by the molar mass of silver AgCl is basically 143.5. So that gives you the answer as around 0.03 moles, right? Now the point here is, because we have been given that we are using excess of silver nitrate solution, the amount of AgCl is actually determined by the chloride ions which are coming out of this particular complex salt, isn't it? Right? And now, because we are getting 0.03 moles of silver chloride, there must be 0.03 moles of chloride ions which must be generated from this salt. So what I mean here is, from 0.01 moles of salt here, we should get 0.03 moles of chloride ions. Okay? And when do we get 0.03 moles of chloride ions? When 3 chlorine atoms are acting as counter ions. Basically, they are present outside the coordination sphere. Okay? If you look at option A, right here, you are having this particular complex. Now when it breaks, when it dissociates into water, what you are going to get is CO, NH3, 3 positive plus 3 Cl negative. Yes or no? So these 3 chloride ions which are generated here, they will be able to combine with silver nitrate solution to produce silver chloride, having number of moles as what? 0.03 moles, right? So definitely your answer here is A. If we look at option B, only 1 chloride ion will be generated. Option D, only 2 chloride ions will be generated. Option C, no chloride ions will be generated here, right? So definitely if you have a look, your answer should be here A. I hope you got the clear understanding with respect to this particular question. Alright, so moving on with the next question here. Question is, in 0.2 molal aqueous solution of weak acid HX, the degree of ionization is 0.3. That means you have been given the value of alpha, which is degree of ionization. taking Kf for water as 1.85, you have been given the Kf value of water as 1.85, the freezing point of the solution will be nearest to, so you have been given different options here, alright. Now, first and foremost thing, they have given us a weak acid which is nothing but HX, and for that they have given us the degree of dissociation, right. Now, if you want to find the freezing point of the solution, we have a direct formula here, that is delta TF is equal to I into Kf into M, right, wherein I is nothing but Van't Hoff factor. But they have not given us the Van't Hoff factor, instead they have given you the value for alpha, okay. So, let's use the relation first of all between alpha and I to get the value of I and then plug in the values here, okay. So, we very well know that alpha is nothing but I minus 1 over N dash minus 1. N dash is basically total number of particles produced from the given electrolyte. So, if I consider here HX, when it dissociates, definitely we are going to get what? H plus and X minus, yes or no? Right. So, theoretically we are going to get 2 particles here. So, N dash here is definitely 2 and alpha is given to as 0.3. So, if I plug in the values here, so 0.3 which is equal to I minus 1 over 2 minus 1, okay. So, definitely here value for I will be equal to 1.3. This will be the value of I, isn't it? So, if you know the value of I, let's plug in the value here. So, delta TF, so delta TF will be equal to T naught F minus TF, because there is depression in freezing point. Now, T naught F is nothing but freezing point of pure solvent, right. So, T naught F minus TF, which is equal to 1.3 times 1.85 times, obviously molality is given to as 0.2, yes or no. Now, we know that T naught F is nothing but 0 minus TF, which is equal to, now when you multiply this, your answer comes out to be nearly equal to 0.480, okay. So, if I want to write the answer here, TF value definitely is negative 0.480 degree Celsius. Why? Because the options which are given to us are in all degree Celsius. So, definitely here option D is going to be your correct answer. Clear? I hope you got the clear understanding. Same way, instead of freezing point depression, they can ask you any question based on boiling point elevation for any given electrolyte. Please make sure you consider I. And of course, I have given you the relation between alpha and I, and accordingly you can solve any such question. Yeah? Alright. Moving on to the next set of questions, which are basically going to deal with chemical kinetics. So, the question here is, the rate of a reaction doubles when its temperature changes from 300 to 310 Kelvin. So, that we already know that for every 10 degrees Celsius rise in the temperature, rate of reaction almost doubles. The activation energy of such reaction will be, now this is a typical question which is actually based on Arrhenius equation. Now, we know the Arrhenius equation here as log of K2 over K1, this is obviously to the base 10, so log of K2 by K1 is equal to EA over 2.303 times R 1 by T1 minus 1 by T2, right. This is the formula. So, 2 different temperatures, 2 different rate constant values. Now, they are saying that rate is doubling. So, obviously, rate constant is going to double, right. So, in short, we can say this particular expression is going to be log to the base 10 2, okay, which is equal to EA divided by 2.303 times R value is 8.314 because we are considering the SI unit here. 1 over 300 minus 1 over 310, okay. Now, log 2 has been given to us as 0.3010, okay. So, now definitely when I find the answer for EA, it is going to be what, 0.301 into 2.303 into 8.314 times 300 times 310 over 10. So, when you solve this, you will realize that your answer comes out to be 53.6 kilojoule per mole, right. Option A is your correct answer here. 53.6 kilojoules per mole. This is again a typical question which is based on the Arrhenius equation. Okay, so please make sure that you know this particular formula. Okay, moving on with the next question. The half-life period of a certain reaction. What is the reaction? That is, A is changing into products, is 1 hour. When the initial concentration of the reactant A is 2 moles per liters. Okay, so basically this is the reaction. Its half-life is 1 hour when its initial concentration is taken as 2 moles per liters. How much time does it take for its concentration to come from 0.50 to 0.25 moles per liters if it is a zero order reaction? Very, very important. It is a zero order reaction. Okay. Now we know that for zero order reaction, the half-life will be dependent on the initial concentration of the reactants, right? So we can say here that T half is equal to A0 over 2K. This is the expression for the half-life when it comes to zero order reaction, right? So obviously 2K here would be constant. So if I take the ratio of these two, because in the second case also they are asking us for the time which is required for the reduction from 0.50 to 0.25. Okay, so half of it basically, right? So in the second case also they are asking you to find the half-life. So let me put it as T half 1 over T half 2, which is equal to obviously A0 1 over A0 2, right? So half-life in the first case is given to you as 1 hour. Second case obviously we do not know, we have to find this, which is equal to, in the first case initial concentration is given to you as 2, in the second case initial concentration is 0.50, right? So when you solve this for the half-life, you will get it as T half, which is equal to 0.50 over 2, which is basically 1/4, right? So hence definitely your answer here will come out to be 0.25 hours. Simple, straightforward. Yes or no? Now if you notice here, initial concentration in the first case we are taken as 2, right? Now it is reduced to 1/4, right? That is 0.5. That's the reason the half-life is also reduced here to 0.25. So definitely here your answer is option C. Clear? Okay, moving on with the next question here. You have to consider one reaction here, that is Cl2 plus H2S gives you S plus 2H plus 2Cl minus. Now this is the reaction. The rate equation for this particular reaction is given to you as rate, which is equal to K times concentration of Cl2 times concentration of H2S. The question is, which of these mechanisms is or are consistent with the rate equation? Okay. Now, first and foremost thing, it is given to you as a complex reaction and its rate expression is nothing but this one. So, rate is equal to K times concentration of Cl2 times concentration of H2S. So, when we look at the mechanism, we must find the slow step of the mechanism and correlate that with the rate equation. So here you have been given these two different mechanisms, and based on that they have been given certain options here. So if you look at the first mechanism here, Cl2 plus H2S gives H plus Cl minus plus HS. Now this is a slow step, very important. Now if this is a slow step, we can say that this is going to be RDS, that is nothing but rate determining step, right? It is basically what? Rate determining step. So for this rate determining step, if I want to write the rate equation, can I say it is basically R, which is equal to K times concentration of Cl2 times concentration of H2S. I hope this is clear. Now don't you think it is in accordance with the rate equation which is given to us? Okay, so definitely option A, I mean this particular mechanism could be regarded as what? A possible mechanism for this particular reaction, correct? Now, let's have a look at the second mechanism here. H2S reversibly gives you H plus and HS minus, right? And this Cl2 plus HS gives you what? 2Cl minus plus H plus and S. Now, here if you notice, the second step is given to you as a slow step. So if I write the second step, if it is a slow step, again it is basically your RDS, rate determining step. And because it is your rate determining step, we can say here that rate equation for this particular slow step is going to be what? R is equal to K times concentration of Cl2 times concentration of HS minus. Yes or no? But the problem here is HS minus is the intermediate, reaction intermediate. And reaction intermediate cannot be a part of what? The rate equation. We have to write the rate expression in the context of the reactants itself. So Cl2 is fine here, but you have HS minus as well, right? Now, if you look at the first equation, HS minus can be correlated to H2S here, isn't it? And what is the ratio of HS minus with H2S? Again, it is 1:1. Okay, so rather than writing this as HS minus, okay, in terms of H2S, can I write this expression as K times Cl2 times H2S, right? So definitely here we can say that HS minus is also correlated to what? H2S, like this, and hence this could be the rate expression here, right? So both the mechanisms could be in correlation with the given reaction, isn't it? And that's the reason we can say here that option B could be your correct answer. That is both A and B, right? So whenever they are giving you any possible mechanism, please look at the rate determining step or the slow step and the corresponding rate equation. Yes? Okay. Moving on with the next part here. The rate law for the reaction between the two substances A and B is given by this particular expression, that is rate is equal to K times A to the power N, B to the power M. Now, on doubling the concentration of A and halving the concentration of B, the ratio of new rate of the earlier rate to the reaction will be. Now, you have been given these options, right? So, first and foremost thing, let us write the original rate equation here. So, here we have rate, let me put it as R1, which is equal to K times A to the power N, B to the power M, right? Now, what they are saying is you are doubling the concentration of A and B concentration you are making it half, right? So, if I write this particular expression again for, let's suppose R2, that is a new rate here, okay, which is equal to K times 2A to the power N, B over 2 to the power M, this expression, okay. So now let us try to rearrange this particular expression. So we can say it is going to be K times 2 to the power N, A to the power N times B to the power M, and we can say 1 by 2 to the power M, yes or no? Okay, let me put this in the concentration term, right? So now again, if I rearrange this, can I say it is basically 2 to the power N times 1 by 2 to the power M times K times A to the power N and of course B to the power M, yes or no? Now we very well know that this particular part obviously is nothing but your R1, that is initial rate or the first, the original rate, okay. So this will be equal to what? 2 to the power N times 2 to the power minus M. So without any doubt, it is going to be 2 to the power N minus M times R1, which is nothing but R2. So what they are saying is the ratio of new rate to the earlier rate. So R2 by R1 is equal to 2 to the power N minus M, which is option D, isn't it? Which is option D here, right? So definitely that is your answer here. So this was the question which was based on the rate expression, rate equation, alright? Okay. The next question, the unit for the rate constant for the second order reaction, is, you have been given these different units here, okay. Now, we know that the direct formula, if you want to find the order, or rather unit for K for a given order reaction, right? So we can say it is nothing but moles per liter raised to 1 minus n s to the power minus 1 per second basically. Now this moles per liter is basically your molarity, right? So instead of writing this as moles per liter, we can put this as capital M 1 minus n s to the power minus 1, wherein n here is nothing but the order of the reaction. Now here they are saying that it is a second order reaction, right? Now because it is obviously the second order reaction, if I put here, so m to the power 1 minus 2 s to the power minus 1, so basically it is m inverse second inverse, right? So definitely here your answer should be B. Now using this particular expression, you can find the units of rate constant for any given order reaction, okay. Counter question for this could be what? They will give you the value of K and they'll ask you to find the order of the reaction, okay. So when they give you such questions, you just have to look at the units of K and from that derive the order of the reaction, right? So I hope you get this clear understanding, so please make sure that you remember this particular formula, okay. Moving on with the next part here. Certain questions now we are going to deal with electrochemistry here. So the question is, the standard reduction potentials for Zn2 plus to Zn, so basically it is zinc, nickel and iron, are negative 0.76, negative 0.23 and negative 0.44 volts respectively. The reaction X2 plus Y giving you X plus Y2 plus will not be spontaneous, when, okay. Now first and foremost thing, let us try to arrange these elements as per their increasing or decreasing order in the EMF series, okay. So the very first element here which will be appearing in the EMF series will be the one which has got relatively higher reduction potential, right? So I put this as 0.23 volts. This is basically your SRP value, okay, standard reduction potential, and without any doubt this is for nickel. What does that mean is Ni2 plus ions will have maximum tendency to get reduced. Now after this obviously you are having 0.44 volts, this is basically for Fe, and finally you are having for Zn, which is this is negative, this is also negative, this is negative 0.76 volts, this is for Zn. Now, one thing is very much clear, that suppose if we consider their reduction potential, their tendency to get reduced, Ni plus will be maximum, then Fe2 plus, then Zn2 plus, right? In other words, we can say that in such kind of displacement reaction, this is basically what a displacement reaction, isn't it? X2 plus Y gives you X plus Y2 plus. This is a kind of in general hypothetical reaction which has been given to us, right? So here what they are saying is this reaction will not be spontaneous. In what cases? Now first thing is very much clear, that Fe will be able to displace Ni2 plus, yes or no? So if X is your Ni2 plus and Y is Fe, definitely this reaction is possible, okay. So option A cannot be the answer. X is Ni and Y is Zn, right? So in short, X is Ni2 plus, Y is Zn, so definitely zinc is capable of displacing nickel ions from its solution, so definitely this is also possible. X is Fe and Y it is Zn, so zinc without any doubt is capable of displacing Fe from its salt solution, Fe2 plus ions, right? Now if I say that X is Zn and Y is Ni, now without any doubt this reaction is not possible. Nickel will not be able to displace zinc. However, zinc will be able to displace nickel from its salt solutions, right? So of all these options, we know that option D should be your correct answer because it is not going to be a spontaneous reaction. Zinc will be able to displace Ni2 plus ions from its salt solutions, but Ni2 plus or Ni will not be able to displace Zn2 plus, right? Why? Because Ni2 plus has a higher tendency to get reduced compared to Zn2 plus. Clear? Okay. Moving on to the next question, the reduction potential of hydrogen half cell will be negative if you have been given these options. Now, this is a typical question, which is based on the Nernst equation. We have to apply the Nernst equation here. Why? Because if you see in all the cases, the concentration like this, the concentration is not 1 molar, and all the more the pressure is also different. Clear? So first and foremost thing, let us write the equation for obviously reduction for hydrogen half cell. Okay. So here you have 2H plus aqueous plus 2 electrons gives you H2 gaseous state. Simple, straightforward. This is the reduction reaction. Okay. Now if I apply the Nernst equation here, you will have E reduction, which is equal to E naught reduction minus 0.0591 over N, that is nothing but 2 here, log to the base 10 of pressure of H2, that is partial pressure of H2 over concentration of H plus ions square. Okay. Now we know that E naught reduction here is definitely 0, right? So 0 minus 0.0591 over 2 log to the base 10 of P of H2 over H plus ions square. Now understand here that this entire value will be negative only if the value of this particular log term comes out to be positive, right? Okay, so let's try to see in which cases you may get value of this particular log as negative or as a positive, right? So if you look at the first one here, the pressure of hydrogen is given to you as 1, so I will put it as log of 1 over 2 square. Okay, so definitely here denominator is higher compared to numerator, so this value is coming out to be what? Negative. So if this is coming out to be negative, negative will become positive. So in this case your E reduction will come out to be positive. So definitely option A cannot be the answer. If you look at option B, you are given H2 as 1, pressure of hydrogen as 1, and H plus ion concentration also as 1. So if I take this as log of 1 over 1, so basically it gives you the answer as 0, and hence in the second case E reduction will be 0. So it is neither positive nor negative, so definitely B also is ruled out. Option C, if you see, log of 2 divided by 1 square, definitely this log value is going to be positive, and if this log value is going to be positive, your E reduction, overall E reduction without any doubt will be negative, right? And let us confirm for option D also here, you are given hydrogen pressure as 2, but H plus ion concentration is also 2, which is nothing but square. So again here denominator is higher. So overall E reduction in this case also is going to be positive, correct? So definitely if you see in all these options, it is option C which is actually complying with the question which is given to us. That should be your answer. So please apply the Nernst equation here and correlate the concentration as well as the partial pressures here, right? The next question here. The Gibbs energy for the decomposition of Al2O3 at 500 degrees Celsius is follows. Now see, the first and foremost thing, you have been given the decomposition of Al2O3, right? The potential difference which is needed for the electrolytic reduction of Al2O3 is at least, you have been given these options, okay? Now, for this particular reaction, you have been given the Gibbs energy value, right? And they're asking you to find the potential difference. And we very well know the correlation between Gibbs energy change and the potential, okay? So we can write here that delta G is equal to negative NFE, right? This is the correlation here. Now, my question here will be to find the value for N, that is nothing but moles of electrons which are involved in this reaction. Delta G has been given to us F also has been given to us, right? So if we know the value for N, definitely we are through with this question. Now in such cases, how do we go about finding the value of N? Okay, now look here. You have been given this particular compound that is nothing but Al2O3, right? So if I say Al2O3, in this the oxidation state of aluminium is nothing but +3, right? In Al2O3 the oxidation state is +3, and this Al2O3 is changing into aluminium and oxygen. So here oxidation state for aluminium is definitely 0. So for one single aluminium, the change in oxidation state is from +3 to 0, isn't it? So if I want to find, so if I say for one single aluminium ion, the change in oxidation state is by +3 to 0. So basically it is by 3, yes? Now in the question, if you notice, there are how many aluminium here? You can see, right? 4 by 3 without any doubt. Therefore, net change in oxidation number for aluminium is definitely 4 by 3 times 3, right? Okay, so here if I am considering this, so definitely here you could have N value as 4, right? So this is the net change, that is nothing but 4. So definitely here N value is 4, and if N value is 4, let's substitute that here. So your delta G value is plus 966 kilojoules per mole. Okay, so let's suppose we are writing that in terms of joules. So here you are having 966,000, which is equal to negative 4 into 96500 into E. Okay, now when you will solve this particular expression here, you will realize that your answer will come out to be nearly equal to 5 volts. Okay, so we at least, so E value is coming out to be negative 5 volts now as per this expression, right? So we need at least 5 volts of electricity so that this particular decomposition reaction will take place. So definitely here option D is your correct answer, right? Now here I hope you got the clear understanding. So here 4 by 3 times 3, right? So your N value is coming out to be 4 here. Now I'm sorry, my bad, here if N value is 4, okay, so your E value should come out to be 2.5. Okay, it will come out to be 2.5. So your answer here should be option C, okay. But you should know the drill of solving such kind of questions, right? So here you are being given delta G and you are asked to find the value for E, right? So if you want to find the value of E, definitely you need to know what is the value for N, and we have found here value of N, and from that we have found the E value, right? So here it should be 2.5 volts, right? Okay, moving on with the next part here. Here you have been given two different E naught values, okay? You have been given two different E naught values. So E naught of Fe3 plus changing into Fe, that is 0.036 volts. And E naught of Fe2 plus to Fe is plus 0.439 volts, okay. So from this they are asking you to find the value for the standard electrode potential. Now this is the reaction which is there, Fe3 plus 1 electrode changing to Fe2 plus. Now you cannot simply add or subtract E naught values for these two reactions. This is a kind of a, we can say disproportionation reaction which is involved, okay, overall I am saying. So in such cases what we need to do is, these E naught values we need to convert them into Gibbs energy changes value, okay. So what we do here is, first and foremost thing, let's write these two reactions and their corresponding delta G naught value, okay. So for the first reaction we can say it is Fe3 plus 3 electrons is changing into Fe. This is my first reaction, right. Now the E naught value here is given to you as 0.036 volts, okay, and how many moles of electrons here are involved? 3 moles of electrons. So for this case, if I write delta G naught, it is going to be negative NF E naught, correct? So here value for N is nothing but 3, so 3 times F times E naught here is 0.036. So when you do this calculation, your value for delta G naught will come out to be negative 0.108 F. Okay, this obviously will be in terms of joules. Now this is the Gibbs energy change we found for the first reaction. Okay, I mean Fe3 plus changing into Fe. For the second one, Fe2 plus 2 electrons is again obviously changing into Fe, right? So for this particular reaction, delta G naught again is what? Negative NFE naught, right? Now in this case, obviously N value is nothing but 2, F and E naught value is positive 0.439 joules, right? So your value here will come out to be negative 0.878 joules, yes or no? Now, I found the individual delta G naught values in both the cases, right? So if I want to find it for the third reaction, what I need to do is obviously I need to do some calculations here. So see, here as far as these two reactions are concerned, you are given Fe3 plus as per the final reaction at the reactant side and Fe2 plus at the product side, okay? So what I need to do is I can flip the second reaction here. So if I flip the second reaction will become Fe giving you Fe2 plus 2 electrons, and obviously its corresponding delta G naught will become positive plus 0.878 joules, right? So if we add these two reactions, so let me write these reactions here. So Fe3 plus 3 electrons giving you Fe, right? And the second here is Fe giving you Fe2 plus 2 electrons, right? So when you add these two reactions, what you are going to get? Fe3 plus 1 electron, which is giving you what? Fe2 plus, which is actually our required equation, yes or no? So the corresponding delta G naught value here, we know that it is negative 0.108 F and this becomes positive 0.878 F joules. Both the cases it is joules, right? So this value will come out to be negative 0.77 F joules. Now this is the value for Gibbs energy for the third reaction, okay? But what they are asking is to find is the standard electrode potential, right? So for the third reaction also, we can correlate delta G naught, which is equal to negative NF E naught, right? Now delta G naught here is negative 0.77 F, which is equal to negative. Now in the third reaction, what is the value of N? Obviously 1 mole of electrons are involved. So 1 times F times E naught. So F gets cancelled here. So you are left with E naught as 0.77 volts. Okay. So looking at this, obviously your answer should be option C, right? So please remember, in such kind of questions, you cannot directly add or subtract E naught values, because we know that E naught is actually intensive properties, okay, whereas Gibbs energy change is extensive, and because of which we can add or subtract these values, okay. So what we have done in such cases is, whatever E naught values were given to us, we first of all converted them into Gibbs energy change values, and eventually we found it for the final reaction, and from there we got the answer for the EMF or electrode potential. Yes. So such kind of questions they can ask you in terms of copper as well, because copper could also exist in what? Variable oxidation numbers, right? I hope you got a clear understanding here. So let's move on with the next question here. The equivalent conductances of two strong electrolytes at infinite dilution in water at 25 degrees Celsius are given below. So here you have been given two strong electrolytes. One is sodium acetate, another one is HCl. Question is, what additional information one needs to calculate is required for acetic acid? Now we know that acetic acid, if I want to find its lambda naught value, it is CH3COOH. So basically it is lambda naught of CH3COO minus plus lambda naught of H plus, without any doubt, okay. Now you have already been given the lambda naught values for sodium acetate and HCl. So from this you get this source of acetate ions right? And from here definitely you get the source of H plus ions, yes or no? Now once you get this particular thing, when you add these two, definitely you are invariably adding the values for Na plus as well as Cl minus, yes or no? You are adding the values for Na plus as well as Cl minus, isn't it? So I need to make sure that these values should be nullified. So if I basically want to find the lambda naught for CH3COOH, it is actually equal to what? Lambda naught of CH3COONA plus lambda naught of HCl minus lambda naught of NaCl. Then only I will be left with these ions. So along with these two data, I need to have the value for lambda naught of NaCl, which is definitely your option B. Clear? So again, this particular question was based on Calder's law of independent migration of ions. The next question. The standard reduction potentials of the three metals A, B and C are given to you. The reducing power of these metals are. Now these questions they can ask you in your entrance level examinations, right? So you have been given metal A, metal B and metal C. Okay? And let us write their SRP values here. Standard reduction potentials. For A it is positive 0.5 volts. For B it is negative 3 volts and for C it is negative 1.2 volts. Okay. Let's write their corresponding SOP values as well. Okay. So their numerical will be the same but the sign will change. So for A it is going to be negative 0.5 volts, B is plus 3 volts and C is going to be plus 1.2 volts. Now they are asking us to write the order for the reducing power, right? Now when we talk about the reducing power, we talk in the context of what? The oxidation potential, that tendency to get oxidized. So the one which gets easily oxidized will be stronger reducing agent without any doubt, okay? So if the one of the element which gets easily oxidized, it means it is going to have a higher oxidation potential or lower reduction potential. Either way it's fine, okay? So if you look at this particular part of standard oxidation potential, you will realize here that B here has the maximum oxidation potential, right? If I am saying that B has a maximum oxidation potential, it means it is going to get oxidized very easily and hence it is going to be a strongest reducing agent amongst these three, right? So obviously B followed by C and finally A, right? So definitely option A here is your correct answer. Yes or no? So this is again comparison question for their oxidation or reduction power. In this case it is reducing power. Similar question they can ask you for the oxidizing power as well. Right? Okay. Moving on with the next question here. How many atoms of calcium will be deposited from a solution of calcium chloride by a current of 25 milliamperes for 60 seconds. Okay, 60 seconds. Now see, such cases they're asking you to find the atoms of calcium, right? If they're asking you to find the atoms of calcium, obviously we can find how many moles of calcium would have been deposited from calcium chloride. Okay, now we know that calcium is nothing but a di-positive ion, yes or no? So divalent ion here. So suppose if I am considering the final expression here, we can say that 96500 coulombs of electricity. Because calcium its valency is 2, we can say it is going to give us half a mole of calcium. Okay, it is going to give us half a mole of calcium. So 96,500 coulombs of electricity will produce half a mole of calcium, which we already know. In the question, you have been given 25 milliamperes for 60 seconds, right? So if I consider that Q value, it is nothing but I into T, right? Now I here is nothing but 25 milliamperes. So 25 into 10 to the power minus 3. Make sure that you are writing in terms of what? Amperes, okay? Times T, which is nothing but 60 seconds. It is first of all going to produce how many moles of calcium, okay? So from here, we can definitely find the moles of calcium which is produced as 1 into obviously 25 into 60 times 10 to the power minus 3 divided by 96500. Okay, so this particular answer will come out to be 7.7 into 10 to the power minus 6. Now these are the moles. These are the moles of calcium which are produced. Okay. Now these moles, obviously we need to multiply it by the Avogadro's number so that we will get the number of atoms. So right, if I consider number of atoms of calcium which is produced will be number of moles times 6.02 into 10 to the power 23, right? Okay, so here number of moles is 7.7 into 10 to the power minus 6 into 6.02 into 10 to the power 23, right? So here your answer will come out to be 4.8 times 10 to the power 18, 4.68, okay, 4.68 into 10 to the power 18. This is going to be your answer. All the options they have given you as same except for the power of 10. So this power comes out to be 10 to the power 18 and hence option A is your answer. So I hope you got the clear understanding with respect to certain questions which are based on electrochemistry. Next few questions we'll be dealing with is the solid state. So the question here is, in a compound, the atoms of element Y, they form CCP lattice and those of element X occupy 2/3 of the tetrahedral voids. Then they are asking you to find what is going to be the formula of the compound, right? Now when they say that Y, it is forming a CCP lattice, so obviously number of atoms of Y could be 4. CCP is as good as FCC, right? So, but in general, we can take any number of atoms for Y. So let's suppose we take number of atoms of Y as N, number of atoms of Y as N, okay? Now, it is going to generate how many tetrahedral voids? Definitely 2n. Yes or no? Because the number of tetrahedral voids is twice the number of atoms. So the number of tetrahedral voids are 2n, of which 2/3 voids are occupied by X. So here X will be equal to 2/3 of 2n, right? So without any doubt, it comes out to be 4/3 times n. These are the number of atoms of X. So if I take the ratio here, X is to Y, so what you have is 4/3 times n is to obviously just n. N gets cancelled, so you are left with here 4:3, right? So without any doubt, the formula of this particular compound should be X4Y3. Clear? Direct, straightforward, okay? So definitely option A is going to be your correct answer. The way we have discussed for tetrahedral voids, exactly similar way, they can ask you any question based on octahedral voids. Please, you should be knowing the correlation, how to apply them, right? And then simply take the ratio, you will get the answer for the molecular formula. Now the next question here is lithium. It forms a body-centered cubic structure. It is forming BCC. The moment they say BCC, one thing is very much clear, that value of Z is nothing but 2. Okay, number of atoms per unit cell. The length of the side of its unit cell is 351 picometers. So what is the atomic radius of lithium? Now here they have been given you the length of the side of the unit cell. Basically they have given you this as edge length. And because it is BCC structure, we know what is the correlation between A and R. So we can put here that 4R is equal to root 3A, isn't it? 4R is equal to root 3A. So definitely R is equal to what? Root 3A over 4, which is nothing but root 3 is 1.71, A is 351. It is perfectly fine if you do not convert here this into meters, because eventually your answer which they are asking you is in terms of picometers, okay? So 1.71 times 351 divided by 4. So when you do this calculation, your answer here, so when let's try to quickly do this calculations here. So here you have 1.71 times 351 divided by 4, right? So that will be near to 150.1. So basically it is your 152 picometers, right? So again, it is a direct formula based question, but you should know what is the correlation between A and R as far as BCC is concerned, right? Now similarly, for simple cubic structure, we know that A is equal to 2R, and for of course FCC, A is equal to 2 root 2R. Please make sure that you remember all these relations here, okay? Moving on with the next part, three elements A, B and C, they crystallize into a cubic solid lattice. Atoms of A occupy the corners, B, they occupy the cube centers, basically a body center, and C, they're along the edge centers. Then what is the formula of the compound? Now, very much clear. Suppose if I draw a cubic unit cell here, right? This is a cubic unit cell. Here atoms of A are along the corners. So here definitely we can put A atoms like this. Correct? Now atoms of B at the body center. So there is going to be just one atom of B here right at the body center, right? And atoms of C are along the edge centers, right? So C atoms we can put it here everywhere along the edge centers. Okay. Now looking at this, they are asking you to find the formula of the compound. Now one thing is very much clear. What will be the contribution of A, number of atoms of A per unit cell? Can I say because they are present along the corners, we can have it as 1 over 8 times 8. That is part of the particle at the corners multiplied by number of corners, right? So definitely here it is going to be 1, right? Okay. Also, because B is present along the body center, it is cube center, so for each unit cell you are going to have one atom of B. So B basically will be 1, right? And C atoms, they are present along the edge centers, right? Now we know that each edge of the cube will be shared by 4 different unit cells, right? So the contribution from each of the unit cell without any doubt is going to be 1/4, correct? So we can say here you are having 1/4 times. Likewise, there are 12 such edges, right? So 1/4 times 12, which is nothing but 3. So when you take the ratio of A to B to C here, it is going to be 1:1:3, right? And that's the reason the formula here is nothing but ABC3. Clear? So definitely option C is going to be your correct answer. Yeah. Again, here they are asking you to find the molecular formula based on the arrangement of these atoms along the corners or along the face centers or along the edge centers, or of course in this case it was body center as well. Clear? Okay. The next part, the ratio of cationic radius to anionic radius in an ionic crystal is greater than 0.732. So its coordination number is, okay. Now this question is based on the radius ratio rule, and we know for different ionic crystals the cations can occupy certain specific voids, isn't it? So in one such relation here, if the radius ratio, that is R plus over R minus, if it is greater than 0.732, then we can say that it is actually, the type of void is going to be cubic, okay, type of void is going to be cubic, and the crystal structure here, crystal structure is going to be BCC, body center cubic structure, right? So if I am saying that it is BCC structure, we have a cubic unit cell here, right? Let's suppose I am drawing this as a simple cubic structure. So all the anions, they are going to be present along the corners, right? And because the size of cation is relatively bigger, it is going to be present along the body center. So right at the center of this particular cube, you will have a cation which will be here, right? So if this is the situation here, this is basically, we can say it is CsCl type crystal structure. Okay, CaCl type, cesium chloride. So the central cation is connected to 4 or rather 8 corners to the anions. Yes or no? They are touching all the 8 corners of the anions. Yes or no? And that's the reason the coordination number here is going to be 8. Right? Simple, straightforward. This was the question which was based on the radius ratio rule. Okay. Moving on with the next question. Glass is a microcrystalline solid, supercooled liquid, gel or polymeric mixture. Now one thing very much clear, it is not a crystalline solid, so definitely A is not the answer, nor it is a gel. Okay. Now we know that glass is actually an example of amorphous solid. Okay, and amorphous solids, they are something which you call it as pseudo solids, right? And these are, another term for something which you call it as what? Super cooled liquids. Okay, so amorphous solids could also be regarded as what? Super cooled liquids, and we know that because glass is regarded as the amorphous solid, it is as good as the super cooled liquid. That's the reason option B is going to be your correct answer. Now the way here the question has been asked in terms of glass, there could be certain other questions wherein they can give you another example and they'll ask you to identify which type of the crystal structure it could be, which type of solid it could be. Like for example, if in a question they are saying that iodine I2 is which type of crystal or which type of solid. Okay, so again, first and foremost thing, it is a crystalline solid. Now in this particular question, the glass is amorphous solid, so there is no other classification. But if you consider the crystalline solid, they are further classified depending on the types of intermolecular forces. Yes or no? So if I consider iodine molecule, without any doubt, it is having a covalent bond between 2 atoms, right? But we are not looking at the interactions which are existing within the molecule. We are looking at the interactions which are existing between the molecules, right? So if I am saying that this is one I2 molecule, you have another I2 molecule here, right? So we can say here that these interactions which are here, they are simply weak van der Waals forces, dispersion or London forces. And that's the reason I2 will be a type of molecular solid. All the more, it is going to be a non-polar molecular solid. Okay. So likewise, as I told you, they can ask you different examples and they'll ask you to identify which particular type of solid it belongs to. So this question obviously was with respect to glass, but I have given you another example wherein iodine, if I say, it is a type of non-polar molecular solid. Clear? Okay. Let's have a look at last question here. Experimentally, it was found that a metal oxide has the formula M0.980. Metal M, which is present as M2 plus and M3 plus in its oxide. The fraction of the metal which exists as M3 plus would be. Okay. Now, first and foremost thing, because it is existing as +2 and +3, definitely it should be belonging to the transition metal series, right? And they have been given you the formula as M0.980. So let us first of all write here metal is existing as, let's suppose, M3 plus and M2 plus, okay? And what are we doing here is, let's suppose M3 plus proportion here is X. Out of 0.98, the proportion of M3 plus is X, then the proportion of M2 plus, we can say it is 0.98 minus X, yes or no? Now we know that this particular compound is electrically neutral. So obviously sum of all the oxidation numbers or all the charges should be equal to 0. So now if I want to find the value for X here, let us first of all write the oxidation numbers of these or total charge present in this particular compound and equate it to what, 0, because it is electrically neutral as such. So for M3 plus, we can say it is plus 3 times X, yes or no? Because plus 3 is the total charge which is present on one single M3 plus ion. So if I say you are having X charges or X M3 plus ion, so the total charge is going to be what, plus 3X plus 2 times 0.98 minus X, yes or no? Now we can say that this is the total charge which is present on the metal, which is including its M3 plus and M2 plus state as well. Oxygen, we know it is minus 2. So sum of all these charges should be equal to 0. Sum of all these charges should be equal to 0, right? Now here you will realize that the value for X, here will come out to be 0.04. When you do this calculation, it is coming out to be what, 0.04. Now this is the amount of M3 plus X which is present in a given sample of metal, right? So if I want to find the fraction, therefore fraction of M3 plus ions which is present into this particular oxide, can we say it is just 0.04 over 0.98 times 100, which is of course close to 4%. So it is coming out to be 4.08%, right? So definitely B is going to be your correct answer here, right? So here what have we done is we have found the total charges present on the metal, obviously the charge on the oxygen, we added them, equated it to 0, and from that we found the proportion of M3 plus, and of course from this you can find the proportion of M2 plus as well. But here because they are asking just for M3 plus, option B is going to be your correct answer, right? So I hope you got the clear understanding with respect to various questions which could be a part of physical chemistry. So that was all from my side. Thank you very much. Done?